You know, people have this idea that physicists are all doing something mysterious, that we've got some kind of magic brain that ordinary people don't have. Let me tell you, that's baloney. What we've got, if anything, is a willingness to think about things a little differently. And I can trace that all the way back to when I was a kid with a screwdriver in my back pocket, trying to fix radios in people's living rooms. I was about 11 or 12 when I set up my first laboratory. Now, when I say laboratory, I don't mean anything fancy. It was an old wooden packing box with shelves in it. I had a storage battery, a lamp bank I'd wired together from sockets I got at the 5 and 10, and I'd cook French fried potatoes on a heater. That was my lab. It was beautiful. It was fun. Pretty soon, people in the neighborhood heard there was this kid who could fix radios for cheap. This was the Depression. Remember, nobody had money for a real repairman, and they started calling me. I'd climb on roofs to fix antennas. I'd rewire circuits, and with each job, I learned something new. But the one that really made my reputation, the one that taught me something important, was the radio that made a terrible noise. This guy picks me up in his beat-up car, and the whole ride over, he's giving me grief. What do you know about radios? You're just a kid. Meanwhile, I'm thinking, so his radio makes a little noise when it starts up. What's the big deal? But when we got there and I turned the thing on, my God, it wasn't a little noise. It was a tremendous racket. Whir! Bill! Bill! The whole thing was roaring and wobbling like it was possessed, and then after a while it calmed down and played fine. And now the guy's standing there waiting for me to grab a screwdriver and start poking around, but I didn't touch anything. I just started pacing back and forth, and he says, "What are you doing? I called you here to fix the radio, and you're just walking around." I said, "I'm thinking." See, I was working it out in my head. If the radio plays fine eventually, but screams at the beginning, maybe the tubes are warming up in the wrong order. The amplifier gets hot before the signal part is ready, and all that energy has nowhere to go except to make noise. So the solution was simple. Swap the tube order so the right parts heat up first. I pulled the tubes out, reversed them, put it back together, and it started up smooth and quiet. That story got around. He fixes radios by thinking. People thought that was remarkable. But all I was doing was asking myself, what's actually happening here, instead of just fiddling with parts. And that right there is the whole trick. That's it. That's the thing that carried me all the way through physics, having a slightly different way of looking at a problem than everybody else. When I got to Princeton for graduate school, I discovered something wonderful. The physics department and the math department shared a common lounge where we'd have tea every afternoon. The mathematicians were obsessed with topology, and they'd sit around proving theorems at each other. One guy would reel off 15 minutes of logical steps, Kirchhoff's this, Waffenstoffer's that, and the other guy would sit there nodding and finally say, "Yeah, it's trivial." We physicists figured out that trivial was mathematicians speak for proved. So we made a joke theorem. Mathematicians can only prove trivial theorems because every theorem that gets proved becomes trivial. But here's the real thing I learned from hanging around those mathematicians. I developed a method that I still use to this day. Whenever somebody's explaining something to me, I immediately start constructing examples in my head. So when the mathematicians would describe their abstract conditions, and you've got a set, it's disjoint, it has certain properties, I'd be building this little mental object in my head. Maybe it's a ball. Then as they add more conditions, the ball turns colors, grows hairs, does whatever it needs to. By the time they state the theorem, I can usually tell you right away if it's true or false, because I've been testing it against my little hairy green ball the whole time. They thought I was some kind of genius. I wasn't. I just had a different method. And here's where it gets interesting. My high school physics teacher, Mr. Bader, once told me to shut up because I talked too much and was bored in class. But instead of punishing me, he handed me a book, Advanced Calculus by Woods, and sent me to the back of the room. That book taught me a technique called differentiating under the integral sign. It turns out this isn't taught much in universities. Nobody emphasizes it, but I caught on to it, and I used that one tool again and again and again. The result was this. When hotshot guys at MIT or Princeton were stuck on some integral, they'd tried all the standard approaches, contour integration, series expansion, and gotten nowhere. Then they'd hand it to me, and I'd try my trick of differentiating under the integral sign, and half the time it worked. I got a great reputation for doing integrals, not because I was smarter, but because my toolbox was different from everybody else's. They'd already tried all their tools before giving the problem to me. This same principle showed up everywhere in my life. At Princeton, the mathematicians were astonished when I could calculate things like e to the 3.3 in my head. It's 27.11, I'd say, and they'd scramble for a table. Turns out I happen to know that the natural log of 10 is about 2.3026, and from radioactivity work, I knew the log of 2 is about 0.693. So e to the 3.3 is just e to the 2.3 times e to the 1. That's 10 times 2.718, or roughly 27.18. Then I'd just correct a tiny bit for the decimal difference. Sheer luck that the numbers they picked happened to decompose into things I already knew. They gave me another e to the 3. That's e to the 2.3 times e to the 0.7, 10 times 2. It's 20.085. They thought I was some kind of computing machine. But if they'd asked me what is e to the 1.73 or something I couldn't decompose, I'd have been dead. That's what I mean about tricks that aren't tricks. It looks like magic, but it's just the ordinary business of having a few extra tools lying around that other people don't happen to carry. The real lesson isn't that I was clever. It's that everybody should go pick up a few unusual tools. Read something outside your field. Learn a technique nobody teaches anymore. Go find your own equivalent of differentiating under the integral sign. Because here's the thing nobody tells you about problem solving. The guy who has the same tools as everyone else is going to get the same results as everyone else, but the guy with the funny old screwdriver in his back pocket, the one everybody laughs at, and sometimes he's the one who fixes the radio, by thinking